Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
For this question, we're considering two cylinders, one copper and one brass, that are stacked end to end. Each cylinder has the same radius, that's the radius r of 0.25 centimeters or 0.25 times 10 to the minus 2 meters. A compressed force is applied to one end, so it's going to be acting on both, and that's equal to 6,500 newtons. And we are asked, based upon the image or the drawing, to find the amount of which the length of the stack decreases. So there's going to be a compression of brass and a compression of the copper. Each one is going to compress by a different amount because they have different Young's moduluses. So the Young's modulus of copper, Y sub C, is written, as well as the Young's modulus of brass, Y sub B. We are also, based on the image, have the original length of the cylinder for the copper, L naught of C, which is 0.003 meters, and the original length for the decompressed length of the brass, L naught sub B, which is 0.005 meters. Okay, so to solve this question, we're first going to consider the fact that in general, the force applied is equal to the Young's modulus value Y times delta L, the change in the length, over L naught, multiplied by the area. Okay, so for us, the total change in length, delta L, is going to be equal to the change in length from the copper, delta LC, plus the change in length from the brass, delta LB. Using the above equation, we can find these values. So delta LC is going to be equal to the force times the original length, L naught, so that's L naught in that expression, sorry about that, times the original length of the copper, which is L naught C, divided by the Young's modulus of the copper, Y sub C, times the area. Cross-sectional area here is pi r squared. And then we're going to add to this the expression for delta LB, which is going to be force, times L naught of the brass, L naught B, divided by the Young's modulus of the brass, Y sub B, again multiplied by the cross-sectional area, which is pi r squared. Plugging these values into this expression, we find that the total delta L value, the total compression from both, is 2.7 times 10 to the minus 4, and the units here would be meters, which we can box this in as the solution to our question.